Great. So let's start here. A little bit of review. This the first, most likely 90% of what I'm doing today is review for you, but I think it's still worth emphasizing. So this is what we did in what you should have done in grade 10 in the intro course. Okay? So what is the slope? I hope you remember what the slope is. Okay? Slope is a numerical value that indicates the steepness and the direction of the line. Is it going upwards or downwards? Okay? So, in a sense, slope, mathematically, right, we would put rise over run. So how much does this line rise? One could also say drop for a certain number of run. So there's a vertical change up and down for a horizontal change. Okay? So vertical, horizontal, and the way we do this, if we have 2 points, we go y2 minus y1, x2 minus x1. Okay? They're all saying the same thing, essentially. Okay? And so 4 types of slopes, I should say. So there's a positive and negative, undefined and zero. So positive, basically what you need is you're expecting the line to go up from left to right. Okay? And the equation would look like this. So if your equation has y and x, you know it's going to be a diagonal line and it's going to go up from left to right. Okay? So I'm going to write down here diagonal, because there's x and y in your equation, and it rises from left to right. Then you've got your negative slope. If you have an equation with that looks like this, y equals mx plus b, then it will go down like that. It's still diagonal because it's got x and y in the equation, and you would say it drops from left to right. It's always left to right. We always read our equations from left to right. Our lines, I should say. So these are the ones that you're most familiar with. And then there's your special cases. These are the 2 special cases. Undefined is simply a vertical line. If your slope is undefined. Okay? So is there a formula? It still looks like, if you go back up, it looks exactly the same. You will just see that m is negative, right? M will be negative when you look at it. Then there's a vertical. This one always looks like this. The equation of this will always be x is equal to a number. If you ever either flat out just see x is equal to a number, you know it's a vertical line, and you know the slope is undefined. And this is the reason why the slope is undefined. Because if you have some sort of a rise and your run is 0, okay, you basically have no run. You're not running sideways. So whatever you would do, if you pick any 2 points on this line and you subtracted them, you would just get a 0 on your denominator. And so that's why is undefined. You cannot divide any number by 0. It just doesn't work. Your calculator will give you an error. Okay. So classic is to know just x is equal to a number. Then you know it's an undefined slope. It results in a vertical line. Okay. Then there's the zero slope. Zero slope is simply a horizontal line. And so your line will always be parallel to your x-axis. The equation will always be y is equal to a number. So you can write down there's just no x variable for this one. No x variable. For this one, let's put a bullet there, no y variable. I will highlight those two. So if there's an x and a y, it's a diagonal line. If there's only an x, it's a vertical. If there's only a y, it's horizontal. Okay? So those are your 4 main types of equations with their respective slopes. So let's graph these guys. Let's practice our graphing again. Good? So, the graphing checklist is there for you, but it doesn't really change. You have to label your x and y axis, choose the appropriate scale, use arrowheads if applicable, and label the line with the equation, right? So graphing by hand. And I will do a mix, but graphing by hand is important. Okay. Let me just check my notes here real quick. Okay. So we're gonna do 2 different methods. This is my preferred method of graphing. Finding the x and the y intercepts. Okay, so we'll just calculate the x and the y intercepts and then connect those 2 intercepts, and that's our line. So I will say this. Look up here. Look at this equation. This is the one we're trying to graph. You don't want there to be x's spread out or y's spread out. You want them combined. So you want to what I call clean it up. Okay. So I will rewrite it. Rewrite and combine. So that counts as well. If there's ever brackets or anything like that, you want to like distribute that out and then combine all your x's and all your y's, and then you want to proceed into graphing. So I'm going to take this one right here, this 2x, and bring it over to the other side. So it ends up being 5x. And what happens to this 2x when it comes over? It changes sign. So if it's 2x, it comes over negative 2x. Plus 2y. And we tend to leave the constant over on the other side. I know that when we did quadratics, we always brought everything over to make it equal to 0, but with linear, I don't do that. So 5x minus 2x is 3x, plus 2y is equal to 6. So this is the cleanup version that I would like you to work with before you proceed with graphing, okay? So this is I'm going to box this in and just say clean version. It's still the same line. I'm not saying that's a different line, but this one is easier to work with. All right. So let's figure out the x and y intercepts. The way I do that is as follows. I'll copy this down. And I make a T-chart like this. And I figure out my x-intercept on this side of the T-chart and the y-intercept on the right side of the T-chart. The only reason I do it this way is to keep everything kind of together in a clean, concise format, because you'll see later on that there's a lot of them that you will be doing, and having it all in one place makes it easier. When you're trying to find the x-intercept, you let y equal to 0. Okay? When is it touching the x-axis? When y is equal to 0. Similarly, when you're trying to find the y-intercept, you let x equal to 0, and then you figure out what y is. Okay, so that's the order. So x-intercept, I basically take this, and I just go 3x plus 2y. Remember, this is the equation we're working with. Y is now 0, okay, and that's supposed to equal to 6. That is really 3x is equal to 6. You divide both sides by 3, because we want to get rid of this, right? X is equal to 2. So you now found that the x-intercept is 2, 0. Okay? That is the point where the line is going to cross the x-axis. Then you go over to this side, and you simply say, whatever x, whenever you see an x, you're going to make that equal to 0. So it's 3 times 0 plus 2y is equal to 6. 3 times 0 is just 0, so you really end up with 2y is equal to 6 on that side. And I made sure these are nice and round numbers, but they won't always be. We will have decimals. So y is equal to 3. So your y-intercept is 0, 3. And this is what I would like you to do when you, because we will be graphing like 2 or 3 lines at the same time. So this is nice to have it like boxed in, and you know these are the intercepts for this particular line. So let's go back a little bit. Given that this equation has x and y variables, we are expecting a diagonal line, either going up or down. Okay, that is something that we are expecting. So let's go and graph this thing. Let me zoom out a little bit. Our points are fairly small, but they will be in the hundreds and the thousands down the road. But we can probably just go 1, 2, 3, 4, 5, going to the right, and going to the left. We go -5. Try to space it out equally. And then you go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. Going 5 in each direction will do for us today. And so then, and I already labeled x and y axis. So the 2, 0 goes here. And the 0, 3 is right. 0, 3 is right there. And you just connect those two. And you have your line. And I will suggest that you label the actual equation on one of the ends of this line, because later when you have multiple, it makes it cleaner. Because if you have lines crossing each other and you cross the labels, then it gets messy. Morning. Can I just mention one more thing? we cleaned this up, but technically you could have used this equation as well. You could have labeled it using that equation. It's still the same line. We just manipulated it. It's not a nice word these days, eh? Manipulate someone. But in this case, it's an equation. We get to do that, right? It's all good. So that's how you graph it using this method. My preferred method, and that's the one that I'm going to use most often. Method number 2, okay? What does it say? Just basically rewrite. Watch what it says here, rewrite at the top. So we'll rewrite it into this format. Y equals mx plus b. We'll start with the y-intercept, which is b, and then find another point using the slope. Okay? So let's do that. Rewrite. And I will copy down the whole thing first. 3x plus 2y is equal to 6. So the cleanup happens every time. And then you have it like this. In this case, we only want the y by itself isolated. You can't see that. Let me change. Let me zoom in a little bit. You want the y isolated, right? So we bring everything else over to the other side. So it's basically 2y is equal to negative 3x plus 6. And our next step here is to divide both sides by 2. So we cancel that out. And then you go, the way we do this, I just want to make sure you understand this 2 is dividing the 3x and it's dividing the 6. Okay, it's affecting both. But we split it up. So we go negative 3 over 2x like that. And we go 6 divided by 2 is 3. So this is our rewritten format. This is the slope intercept. I don't know if you remember that from last year. It turns out that this is m, okay? M is negative 3 over 2. It's our slope. Whatever's in front of x, that's our slope. We can tell that this is that diagonal scenario because we've got x and y. The slope is negative, so you're expecting your line to be diagonal and to drop from left to right. I want you to know that, okay? You need to expect something like this from that. And then our b is this latter part here, which is 3. That tells us that the y-intercept is 0, 3. Okay? Immediately from that, you can derive that. You remember that stuff? Someone? I hope so. And so when you have this, you can start here and then use your slope to find other points. Okay? So we start here. Start here. So watch what I'm going to do. I'm just going to do the same scale as the other one. So I start with 0, 3. It seems to be a negative there. Can you make sure it's 0, 3, right? It's just 3, not negative 3. So you start there. You go 0, 3. You make your point there. And you use your slope to find another point. Slope is negative 3 over 2. Which means that vertically we're changing 3 units down. So we're going to go 1, 2, 3. And horizontally, we're moving 2 units to the right. 1, 2. That's how you find your second point. So we went 3 units down, and we went 2 units to the right. And that's technically good enough. I don't know if they told you in intro, like you have to have at least 3 points. That's actually not right. Like 2 points is all you need for linear. Okay? So you could do 3, 2 again one more time, but I don't find it necessary. I've got my 2 points, and there is my line. Okay? And on one of the, I'm going to just label it with the equation here, 3x plus 2y is equal to 6. It's the same line, but different strategies of graphing. Where one, we just found the x and the y-intercept. The other one we rewrote the equation, and then we started with the y-intercept, and then we used our slope to find more points. I just want to make sure you understand, if this had been positive 3 over 2, then we would have gone up 3 and then over 2. Right? Our line would have been, our second point would have been up here somewhere, and it would have actually been going up from left to right. Okay. So this is review technically, but I hope that helps you. Okay. You know what? I like highlighting, and for some of you, this seems like it's brand new. So I'm just gonna say this -3 here is this stretch right here. Okay. And the 2 is that stretch right there. So if you like highlighting, that's what I did there. By the way, note, I will just tell you this here, -3 over 2 is the exact same thing as 3 over -2. I don't know if you were told that. It still makes the whole fraction negative no matter what. So both of these are going to give you a line that's pointing down from left to right. Mr. Rickson, how is it, if the negative is here, how does that work? Isn't it like you go up 3 and left 2? Yeah, that's true. You would go up 3 and you would have to go 2 units to the left. So your second point would have been up here. But if you connect them, you still get the same line. You know what I'm saying? So it's the same line, just a slightly different strategy. So what I tell my students, I always make the negative float up. So if, let's say you do some math and you end up with the negative here, I just always put it up here. It just makes it easier to work with. But it's up to you what you want to, just be consistent, okay? Okay, hold on. Before I move on, I'm just going to walk you through scenarios, because if you just hear me talk all day, you're going to fall asleep. I know it. What if you clean up, quote unquote, you clean up, and you end up with only an x, like that? What kind of a line are we expecting? You go back to your 4 slopes, right? The 4, it's going to be a vertical line. Exactly. Okay? If you do a cleanup and all you have is y and a number on the other side, it's going to be a horizontal line. Okay? So that's how that works. And specifically, let me go back here. I'll just let you today find out for yourself. When you come across that and you're not sure, just ask me. But if you end up with x is equal to +3, x is equal to +3, then you just, it's saying that x is equal to 3, so the line will be going through x is equal to 3. Right? If it's a line x equals -2, then the line will go through -2 here. Okay, so whatever the number is, that's where it's going through. Same with y. If it's y is equal to 5, then the line will go through 5 If it's -5, then it will go through -5. So you will find out when you clean it up what that number is, okay? I will tell you this. Should I do one at least? I'll do one at least, okay? Let's go to 5. These are the special cases. If you have like terms on either side, combine them before you start graphing, okay? If you have like terms, combine them before you start graphing. This will not be very frequent, but that is why you need to keep these in mind, okay? So we have x's and x's, right? We don't like that, so we'll bring that over. We've got y and y. We don't like that. We'll bring that over as well. So that gives us 2x. This 3x comes over subtracting. So we'll go minus 3x. Then there's this negative y there on the left side. And this y comes over, changes sign. It's negative on the right side, comes over, adding. Okay. And any constants, we bring them over to the right. In this case, the 4 is already there, so it just stays. No change of signs or anything like that. So now combine. 2x minus 3x is negative x. The negative y and the positive y, they simply cancel out. So you end up with 4. Only x present, right? Vertical line. You know there's going to be a vertical line, so you don't have to find the y-intercept or anything like that. But we don't like the variables to have a negative in front. So what do? We divide both sides by -1. So x is equal to -4. This is our line. This is the equation. Okay, this is the equation that we're after. So this actually makes things, if you know what you're doing, it makes it a lot easier to graph. So all we're going to do is this. We're going to go to -5 here. And because it's x equals to -4, we go to -4 right here, and we draw our line. This is x is equal to -4. You're done. And think about it differently. It's saying no matter what, x is always equal to -4. No matter what, like no matter where we are, x is always equal to -4. That's what we're told. Slope is undefined. A lot of times students, and I ask them, what's the slope of this graph or of this equation? Oh, it's 0. It's not true. It's undefined. Okay? It doesn't exist. And the only reason I'm going to do the next one as well is because I know how sometimes you study and you go through your notes. If it's blank, you're not going to notice it. You will remember now if I tell you, but later on you might forget. So I will do this one as well. This is my other special case here. There's y and y. There's only y's, by the way. That's something to note. So bring this one over. We don't want constants on the right side, so bring that one over here. So it's half y minus y half y is over here, minus y, and on the other side we've got negative 5 plus 2. What's half minus y? It's negative half y is equal to negative 3. And I think I'm just going to tackle this a little differently. When you have a fraction in front of a variable, you can also just write it like this. You go 1 times y as y, and then you divide it by 2 is equal to negative 3. And so what I will do now is I'll multiply both sides by 2. It's a little longer than you would like it to be. So it's negative y is equal to negative 6. And then we divide by negative 1. And you end up with y is equal to positive 6. This is the equation. It's a horizontal line. Okay? So we graph this. 1, 2, 3. This is 5. So 6 is up here. So you just go take your ruler. You graph it. This is the line y is equal to 6. All right, I'm going to stop there. That's right. I'm going to assign pages 9 to 8. Sorry, that doesn't make sense. 6 to 8, sorry. 9 to 8, how does that work? You mean 8 to 9? Pages 6 to 8. So before we start, I'm just going to remind you what the instructions say. I kind of want you to follow that pattern. So let's go to page 6. And it just says, for each of the following, determine the intercepts, so the x and the y intercepts. Okay, that's what I mean by that. Rewrite it into this format as well, and then graph using the method of your choice. You can either use this equation or you can use the intercepts, whichever one you want. Remember to clean it up first, okay? I will make a note at the top of page 6 here. Clean up first, okay? Should look like this before you start. 3x plus 2y is equal to 7, for example. If you have constants on the left side, bring it over to the right side. If you've got x's on both sides, make sure all the x's are on the left side, right? So that's what I mean by cleaning it up. If it's already cleaned up, if it looks like this, you're done. You just follow just do these 3 things that I'm asking you for, okay? All right, that's it. Thank you.